Now let's look at some special right triangles. From geometry, we've looked at a lot of what we call 30, 60, 90s, and it's referring to the angle measurements, 30 degrees, 60 degrees, 90, and also 45, 45, 90s. Now here's the relationship. These x's can refer to any number. On a 30, 60, 90, if the shortest leg over here, let's just say the shortest leg had a length of 9 inches, what would always be true in a 30, 60, 90 triangle is the hypotenuse would be double that. It would be 2 times the value. So this would equal then 18 inches. And this side would be, again, since 9 is x, 9 times the square root of 3 inches. And for most of our computations, we would just leave it like this. We would not reduce it to or change it to a decimal number because square root of 3 goes on forever. We would just leave it like this and call this an exact answer. Just the same, now let me erase this. Let's say we were down here and we were given that this length is like a 9 or something. You could solve for x and determine what these side lengths are. So let's try this out using these examples. So the first one's a 45, 45, 90, and we have 18 here. Now if I go over to this reference back, the hypotenuse is x square root of 2. And so I'm going to say this 18 equals x square root of 2. That's why I'm going to set them equal to one another. Now I'm supposed to determine this length, this x. So to solve this, I need to get x by itself. So here's what I would do. I would set up that 18 equals x square root of 2. Now many people, when they try to solve this, they think, oh, I need a square, because we have such a habit of saying what cancels out a square root is a square. But we're not solving for the 2, we're solving for the x. The idea is this. What mathematically is happening between the x and the square root of 2? They are multiplying. So what's the opposite operator of multiplication? The answer is division. So what I need to do is divide by the square root of 2. And that gives us x. So what is x? X would be 18 divided by the square root of 2. Now if you were in AP Calculus, this answer would be acceptable. At least in the year 2019, they'd accept this because it's an exact mathematical answer. But many people don't consider this good math because we don't want to leave a radical in the denominator. So the way to get rid of it is you multiply by the radical, top and bottom. Now when I write this out, what you'll see is when you multiply by the square root of 2 divided by the square root of 2, that's technically multiplying by 1. So it's not like I've changed the problem. I'm multiplying by 1 on both sides because square root of 2 divided by square root of 2 is 1. But rather than canceling those out and saying that's equal to 1, here's what I'm going to do. I'm going to multiply across. So I'd get 18 square root of 2. You don't multiply something outside the square root to something inside. So I would just leave it 18 times square root of 2 over, now the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is simply 2. So I'm going to erase this here. Now I'll leave it here. And I'll just write it a second time. 18 square root of 2 over 2. And now we can reduce this further. We can say, oh, 2 can go into 18 9 times. That goes in 9 times. So my actual answer is that x equals 9 square root of 2. This would be my best answer right here. Again, both of these on AP Calculus, this one in black and this one in blue would be acceptable. But this is the more traditional answer here that we don't have the radical in the denominator. Now let's try this one. Here we have the 21 on, if you want to think of these three legs as being, this one being the middle, the medium-sized side of the triangle, or you can think about it, if these are the two legs, the longer leg, I'm going to the medium-sized side with 21. So I'm going to go back to this model, and on the medium side, which is this one, we have 21. So 21 equals x square root of 3. So 21 equals x square root of 3. And I need to solve for the smallest side. So I look at the smallest side. The smallest side is x. I want to find out what x is here. So to find x, I need to solve this. So we'd have 21 equals x square root of 3. Again, the math, what's happening is this is multiplying. So to get x by itself, I need to divide. Like this. Now I have x by itself. So if x equals 21 over square root of 3, if I was in AP Calculus, this answer would be acceptable. But here, we don't usually leave it that way. I'm going to multiply by square root of 3 over square root of 3. Again, that's like multiplying by 1. So if I multiply across, I'm left with 21 square root of 3. Here, I get the square root of 9, and the square root of 9 is 3. So what happens in the denominator is the square root just goes away. That's just kind of the shortcut. Now, can this reduce? Yes, it can. This becomes 7 square root of 3. And so that would be our answer, is 7 square root of 3. And I'm going to go one further. Let's say we had to find this side as well. Let's call that y. That's now the hypotenuse. If you go back to this triangle, the hypotenuse is 2 times x. So now that I know what x is, I could say that y would equal 2 times x, which would equal 2 times 7 square root of 3. And you just multiply the things on the outside, and so we'd have that y equals 14 square root of 3. So I just kind of added that in, even though that wasn't originally there. Now I have one for you to try.